We've covered strings at some length already, but we'll take time now to explore their capabilities in a little more depth. Recall that str is a homogeneous, immutable sequence of Unicode code points, which for the most part we can consider to be the same as characters. Let's put str through its paces. As with any other Python sequence, we can determine the length of a string with the built-in len function. For instance, if we wanted to know how many characters were in the Welsh place name Llanfair Pŵl Gwyngyth Goga Ucheldopoth Llantysilio Gogogok, we could call len on this string and get the answer 58. Concatenation of strings is supported using the plus operator. For instance, it's easy to turn new found land into Newfoundland. Although for joining large numbers of strings, the join method should be preferred because it's substantially more efficient. This is because concatenation using the addition operator or its augmented assignment version can lead to the generation of large numbers of temporaries, with consequent costs for memory allocation and copies. Let's see how join is used. Join is a method on str which takes a collection of strings as an argument and produces a new string by inserting a separator between each of them. An interesting aspect of join is how the separator is specified. It is the string on which join is called. As with many parts of Python, an example is the best explanation. To join a list of HTML color code strings into a semicolon separated string, we call join on the separator we wish to use, the semicolon, and pass in the list of strings to be joined. We can then split them up again using the split method, which we've already encountered, but this time we're going to provide its optional argument. A widespread and fast Python idiom for concatenating together a collection of strings is to join using the empty string as the separator. The way may not be obvious at first. To concatenate, invoke join on empty text. Something for nothing. This use of join is often confusing to the uninitiated, but with use, the approach taken by Python will be appreciated as natural and elegant. Another very useful string method is partition, which divides a string into three sections: the part before the separator itself, and the part after the separator. Partition returns a tuple, so this is commonly used in conjunction with tuple unpacking. Here we separate the string London:Edinburgh into three by partitioning around the colon. Often we're not interested in capturing the separator value, so you might see the underscore variable name used. This is not treated in a special way by the Python language, but there's an unwritten convention that the underscore variable is for unused or dummy values. This convention is supported by many Python-aware development tools, which will suppress unused variable warnings for underscore. One of the most interesting and frequently used string methods is format. This supersedes, although does not replace, the string interpolation technique used in older versions of Python, and which we do not teach here. The format method can be usefully called on any string containing so-called replacement fields, which are surrounded by curly braces. The objects provided as arguments to format are converted to strings and used to populate these fields. The field names, in this case 0 and 1, are matched up with the positional arguments to format, and each argument is converted to a string. A field name may be used more than once, such as in this example. However, if the field names are used exactly once and in the same order as the arguments, they can be omitted. If keyword arguments are supplied to format, then named fields can be used instead of indexes. Note in this example how we've used the ability to split long statements over multiple lines so long as the split is inside open parentheses, brackets, or braces. In this case, we split the argument list to the format method inside its open parentheses. This technique can greatly aid the formatting of Python code whilst keeping a manageable line length. It's possible to index into sequences using square brackets inside the replacement field. Here we've assigned a tuple to a variable pos, and then we pass pos as a keyword argument to format. We access the elements of pos inside the replacement fields within the string. We can even access object attributes. Here we pass the whole math module to format using a keyword argument. Remember, modules are objects too. Then we access two of its attributes from within the replacement fields, pi and e. Format strings also give us a lot of control over field alignment and floating point formatting. Here's the same with the constants displayed to only 3 decimal places. We don't cover all of the intricacies of the Python formatting mini-language. If you want to know more, consult the documentation. Now we've covered the fundamentals of the string type, we recommend you spend some time familiarizing yourself with the other string methods. Remember, you can find out what they are using simply help str. Let's move on now and look at the next collection type.